Hello, my name is Jesse Parker, and today we will be doing a technical review presentation. The National Priority List. The site we will examine today is named AVCO or Avco Lycoming. Avco or AVCO Lycoming is located in Williamsport, Pennsylvania, based on the National Priorities List. The site score for the facility was listed at 42.24. Just a little background about AVCO or Avco Lycoming. The Avco Lycoming is a 28-acre Superfund site located in Williamsport, Pennsylvania. The site has been producing aircraft engines for over 50 years. Historic operations at the site contaminated the groundwater with volatile organic compounds and metals. Between 1989 and 1991, EPA conducted a remedial investigation study at the site to determine the type and extent of contamination. The results of this study showed that both the shallow and deep aquifers were contaminated with TCE and DCE and vinyl chloride. Health and environment. The cleanup activity. In 1985, prior to EPA's involvement with the site, the Pennsylvania Department of Environmental Protection, or PADEP, ordered Avco Lycoming to complete a groundwater investigation and cleanup. The company complied with the order by evaluating the on- and off-site shallow groundwater contamination, installing and regularly sampling groundwater monitoring wells, and installing 3 on-site and 2 off-site recovery wells, as well as treatment facilities. A study conducted between 1989 and 1991 identified all types, quantities, and locations of contaminants on site and developed strategies to address them. Based on the results of this study, EPA issued a record of decision in 1991, which called for the contaminated shallow groundwater beneath the facility to be extracted, treated, and discharged to nearby Lycoming Creek. A 1985 consent order and agreement between Avco Lycoming and PADEP was made to address the off-site contamination. As much as they thought this was a good idea, later on we come to see that dumping this contaminated water into Lycoming Creek only made way for future problems to come. Health and environment. A human health risk assessment at the site identified several contaminants present in the groundwater. These contaminants included TCE, DCE, vinyl chloride, manganese, chromium, and cadmium. The human health risk assessment determined that there was a potential risk for human health if anybody were to unfortunately ingest the contaminants found in the groundwater. It also noted that there was an actual or potential future risk to public health, welfare, or the environment if the site was not cleaned up. Human health risk assessment. For all human health risk assessments, the first thing to do is establish the SURPRO plan. The first thing you want to do is identify the who and what so you have a clear, concise examination scope. The second thing to do is identify the hazard of concern and where they occur. The last and final step would be to identify the impact and health effects, both short and long term. Alright, here's a little example of how the 4 steps of risk assessment process works. So first you see we have hazard identification, what problems are caused by the pollution. Then we have dose response, what are the health problems at different exposures. Risk characterization, what is the extra risk of health problems in the exposed population. But also leading up to that, along with the dose response, is the exposure assessment, which is how much of the pollutant that people are exposed to during a specific time period and how many people are exposed. Hazard identification. Hazard identification is the process of determining whether exposure to a stressor can cause an increase in the incidence of specific adverse health effects. It is also whether the adverse health effect is likely to occur in humans. Toxicokinetics consider how the body absorbs, distributes, metabolizes, and eliminates specific chemicals. This is important because it would allow us to relate the dose of a substance to its potential toxicity and better interpret the results of toxicity studies, ultimately contributing to the assessment of human health risks from chemical exposures. Toxicodynamics focuses on the effects that chemicals have on the human body. This is important because it allows us to see the adverse effects, assess the risk to the public, and even develop remedies. Dose response. The relationship of dose response describes both the likelihood and severity. This can be done in 2 steps. Take assessment of all available data, both seen or examined by experiments, make an estimation of risk, and make inferences to examine where the dose level begins and its adverse effects. Exposure assessment. Different kinds of doses, range exposures, quantifying exposures, which has 3 parts: the point of contact measurement, scenario evaluation, and reconstruction. Risk characterization. A risk characterization conveys the risk assessor's judgment as to the nature and presence or absence of risk, along with information about how the risk was assessed, where assumptions and uncertainties still exist, and where policy choices will need to be made. Ecological risk assessment. Step 1 is problem formation, which has 3 objectives, which are refine objectives for risk assessment, determine each ecological entities are at a risk, and determine which characteristics are important to protect. Second is analysis. The objective is to evaluate ecological responses to stressors under exposures of interest. And third, risk characterization. The objective of the risk characterization phase is to use the results of analysis to estimate the risk posed to the ecological assessment endpoint. All right. So first up we have of the ecological risk assessment is problem formation. So see, during problem formation is where you plan ahead, but also gather data, interpret, and monitor. All right. Second, we have analysis of exposure and effects. Unlike problem formulation, you have your planning completed already, but you're still gathering data, interpreting, and monitoring your effects. Lastly, we have risk characterization, which ties into your planning of problem formation, gathering data, interpreting, and monitoring. Also, taking your analysis of exposure and effects, adding a risk characterization, which you then communicate your results, and that is how you assess your risk management. Recommending health and safety. Action 1, collect existing information about workplace hazards. When we say collect existing information, that means like educate your staff on exits and fire hazards, educate them on how to handle it and how to operate the environment around them in case of the hazard was to take place. Inspect the workplace for safety hazards. That's where your fire alarms come into place and your windows. Just making sure your environment around you is safe so things like this do not have the chance to elevate. Identifying health hazards. So this is where you and staff go around, or you and anybody in particular go around and identify all hazards, but also come up with ways to protect and engage in them safely. Conduct incident investigations. This is where you monitor your equipment, monitor your machine work, anything you use, and you make sure it's up to date so you don't have any hazards come into play. Action 5, identify hazards associated with emergency and non-routine situations. And lastly, Action 6, characterize the nature of identified hazards, identify interim control measures, and prioritize the hazards for control. If you want a little bit more insight, here are the 4 sites that I used to get the information. If you want to take a chance to look at other states alongside Pennsylvania, you can use these sites to do that as well. Thank you.